Have you ever really thought about how you organize your kitchen pantry? It seems obvious, right? You put the things you use every day, like your coffee, right at the front where you can grab them easily. It's just intuitive. But what if I told you that in the world of these giant, hyper-efficient warehouses, that simple logic gets turned completely on its head? This is where things get really interesting.
Think about it. Your coffee, that cereal you love, the olive oil, they're all probably within arm's reach. You never hide your most used items behind, I don't know, a giant bag of flour you only touch twice a year. The rule is super simple. The more you use it, the more convenient it should be. You're actually, without even realizing it, optimizing for your own time and effort.
So you would think a massive warehouse, a place where every second and every inch can mean millions of dollars, would follow the exact same rule, just on a much, much bigger scale. The most popular products must go in the best spots, right? Well, not always. And the reason why reveals a hidden logic that pretty much powers our entire economy.
To solve this puzzle, we've got to step inside the warehouse itself. And we're not talking about your local storage unit. Nope, we're talking about a massive distribution center where efficiency is absolutely everything. So let's get our bearings.
Okay, so here's the basic layout. You've got an order picker, and they're grabbing cartons from that convenient bottom level of these giant racks. That ground floor is easy to get to, it's fast, it's efficient. But when a pallet on that ground floor runs out, a forklift driver, the restocker, has to go way up high into the overstock area, grab a whole new pallet, and drop it down into that empty slot.
That super convenient ground floor area? It has a special name, the forward pick area. You can think of it as the beachfront property of the warehouse. It's where every single product wants to be, because picking from here saves the most time and effort. But just like actual beachfront property, there's not a lot of it to go around. And this, right here, is where our simple pantry logic starts to fall apart. Because that prime real estate comes with a hidden cost, a cost you definitely don't have in your kitchen. And that's the cost of restocking. See, every single time an order picker empties a pallet in that prime forward area, someone has to go get another one from the massive, less convenient reserve area, those super high shelves we saw, and bring it all the way down. This whole restocking process isn't free. It takes time, it takes fuel, it takes labor. It's like a constant hidden tax on convenience.
And this is where the numbers get really critical. On average, it can take a forklift about 3 minutes just to do one of these restock moves. Now, 3 minutes might not sound like much, but when you're doing this hundreds, maybe thousands of times a day, those minutes add up to a huge operational cost. Suddenly, putting a really popular item there might mean you're just constantly paying this 3-minute tax over and over again. So how in the world do you decide what's worth the cost? You can't just go by what's popular anymore. You need a smarter way to measure the real value. And this is where warehouse logistics experts came up with an elegant little piece of math to solve it.
This is the key. It's an idea known as bang for buck. Now, I know the formula might look a little intimidating, but the concept is actually really simple. It just calculates the net labor savings you get for giving a product one of those prime spots. It basically asks, how much time do we save on picking it, minus how much time do we spend restocking it, all divided by how much space the product takes up. That's it.
Let's look at a real example. We've got two products here, SKU A and SKU B. Now, look at SKU B. It's way more popular. 1,000 picks versus only 600 for SKU A, and it sells 5 times the volume. So based on our pantry logic, SKU B should get the prime spot, no question about it. But when we actually run the numbers, the result is completely backwards from what you'd expect. SKU A, the less popular item, is the clear winner. It gets a bang for buck score of 180, while the super popular SKU B only scores a 140. So what's going on? Well, even though SKU B is popular, people order it in huge quantities, which means you have to restock it constantly. That restocking cost just eats away all the savings from the frequent picks. SKU A actually provides more value per location.
And there it is. That's the solution to the mystery. In a massive warehouse, popularity is not the only thing that matters. You absolutely have to account for that hidden cost of restocking. An item that's picked often but in small amounts might be a way better investment for that prime real estate than a blockbuster item that needs constant, expensive replenishment.
So this bang for buck calculation leads to this really fascinating and fundamental principle that governs how these giant spaces are organized. It's called the law of none, min, or all.
The logic is actually pretty brilliant. For any given product, there are really only 3 smart choices. 1, its bang for buck is just too low, so you store none of it in the forward area. 2, you store the absolute minimum amount you need to avoid running out.
giving it just enough prime space. Or 3, if the item is so valuable and you have so little of it, you put all of it forward and get rid of the restocking cost completely. Anything in between min and all is just inefficient.
You know, a great way to think about this is like an auction. That forward pick area is like a bunch of exclusive properties up for sale. Every single product in that warehouse calculates its bang for buck score, and that score is its bid. The products with the highest bids, they win those limited, valuable spots. It's this ruthless mathematical competition for space that's happening 24/7.
So why did we just spend all this time talking about pallets and forklifts? Because this isn't really just about warehouses. This is a masterclass in systems thinking. This whole process is about optimizing a system where resources, in this case, space, are limited. And you do it by finding and accounting for those hidden costs, like restocking time. That same logic applies everywhere. I mean, think about how a city designs its bus routes, or how a hospital schedules operating rooms, or even how you manage your own time and energy. The most obvious choice isn't always the most efficient one.
So the next time you see a delivery truck or get a package at your door, just remember the hidden logic that made it all possible. And it kind of leaves you with a question to ponder. What other parts of your daily life, from the layout of the grocery store to the flow of traffic, are secretly being optimized by some invisible equation you've never even noticed?